Ladies and gentlemen, thanks for coming. My name's Rob. I organize Idea the IPO. Appreciate everybody coming tonight. It's daylight savings time. There's daylight, you're here. And also, we're in San Jose. I know how bad the traffic can be. So we've been doing events in Silicon Valley for a number of years. We now do events from San Jose to San Francisco multiple times a week. We have a very, very busy calendar all the time. I'd like to highlight a few events that are coming up next week. So Tuesday, May 12th, we have Bill Reichart of Garage Technology Ventures. He works with Guy Kawasaki. We get him a couple times a year. So he's going to take elevator pitches, and he's going to talk about what constitutes an effective pitch from his standpoint. So that's one of our showcase events, so check that out. Wednesday the 13th, our partner, the Commonwealth Club, has a talk with Ariane Huffington and Sheryl Sandberg. So that's 12 noon at the Santa Clara Convention Center Theater, and our members get the Commonwealth Club member rate, even though you're not a Commonwealth Club member. So check that out. The 14th of April, which is right before tax weekend, who's done their taxes already anyway? Okay. Well, anyway, so you guys can come. If you guys haven't done your taxes, you should probably do that. But anyway, so April 14th, Gary Jinks, How to Get Funded. We've had him speak for many years, and it's always a popular event. And he just came back from being in Saudi Arabia for a couple of months. He was helping them launch an accelerator there. So Gary has a lot of good stuff to say about funding, so check that out. So all the events and all the details are on our site, ideatheipo.com. So we were launched officially February 1st, 2010. We had 0 members and 0 events on our calendar. At this stage, we have over 40,000 members, done all our meetup groups in the Bay Area. We've completed over 1,506 events. We're the most active startup event organization in the Bay Area, bar none. You guys have good timing. Not every crowd has good timing like that. But when I say that, I'm not bragging, I'm just stating a fact. Our mission is to promote entrepreneurship, support entrepreneurs, build community, and provide value in the Silicon Valley startup ecosystem. So we provide content that's practical, actionable, and relevant. We believe in community, so we have a lot of events all the time. So even if you're new in town, you don't know anybody, if you come on a regular basis, you'll build relationships, build a network. And I forgot to mention that we have a TGIF mixer on Friday the 15th and on Friday the 29th at the Hyatt Regency Santa Clara, just a few miles from here. So it's a free event, it's just socializing, so you're all welcome to come. Who usually has plans on Friday night? Well, I figured some of you guys wouldn't, but you guys are all welcome to come anyway. With regard to value, it's important that we provide value at every one of our events because a lot of entrepreneurs are struggling. We know some of them are broke. But value not just for your money, which is important, but more importantly for your time, which is your most valuable resource. Is anyone here getting any younger? Maybe you, right? Yeah, just kidding. But anyway, so value is important to us. So we have a lot of partners that help us to do what we do, law firms, venture capital firms, angel investor groups, incubators, accelerators, colleges and universities, and lots of other players in the Silicon Valley startup ecosystem. Tonight, we're grateful to Coding Dojo for hosting us at this beautiful school. We've done a number of events with Coding Dojo in the past, and we're honored and privileged to be collaborating with them. So let's give a hand to Coding Dojo. Well, they're stoked. That's because they got free pizza. So though one of our missions is to support entrepreneurs locally, our greater mission is to democratize entrepreneurship globally. So to that end, we have a robust YouTube channel. We have lots of videos on all kinds of topics related to entrepreneurship. It's available on demand, anytime, anywhere, free of charge, whether you're in Palo Alto, San Jose, Maui, or Timbuktu. Who's been to Maui? That's cool. Who's been to Timbuktu? Dude, and they have Wi-Fi there too. So my point is, anywhere there's Wi-Fi, you should have access to the same quality content here in Silicon Valley, even if you're living on the other side of the world. So that's an important mission to us. So one of our partners in this mission is Tim Jeggers of Jeggers Films. I'd like to have Tim come up and say a few words.
I'm Tim. If you didn't notice, I'm doing the camera stuff. I've done a couple of videos on the YouTube channel. I've been working with Rob for a while now, and Doing this for a long time, worked for myself all around the Bay Area for like 10 years now. Just kind of transitioned to like full-time, took the jump, entrepreneurial, Bay Area, all that fun stuff. So yeah, that's pretty much my thing. If you got questions about any multimedia, video, photography, I'd be more than happy to get you information or point you in whatever direction might help you out. Yeah, pass it back to Rob.
So check out our YouTube channel, youtube.com/ideaIPO. So we are going to videotape tonight's event, and I want to ask you guys to do me a favor. So the audio is really important. This mic is to record, not to amplify. Someone always says to me, oh, it's not working. Well, it's recording. So when you see a video presentation and you hear an answer during the Q&A session, it's very helpful to hear the question from the original questioner versus the answer repeating the question, or sometimes they'll forget or they'll paraphrase. So that's really important to us. So we'd like you to set aside your questions for the Q&A session. And if you have a question, raise your hand. I'll come by with the mic. And that'll go a long way towards producing a really quality video that you can use as a resource over and over and over. And if you can't wait for the Q&A and you really have to ask a question, that's okay. Just raise your hand and I'll come by. So I thank everybody for your cooperation. So without further ado, I want to introduce our featured speaker tonight. He's a technologist. He's an educator. He's a dynamic speaker and an entrepreneur. So let's hear it for Jay Patel.
Thank you, Rob. Cool. So let's have a show of hands of how many of you are technical, have technical expertise, moderate to very experienced. Awesome. Cool. So this is Web Architecture for Dummies. It hopefully should apply to everyone, but we're going to be targeting the fundamentals. We're going to be going over kind of the basic model and how that's applied to the web. The goal of this is, by the end of it, if you were to talk to a developer, you may not know how to use a particular technology that they're talking about, but you know what its purpose is. That's the goal. You know what the purpose of all of these technologies are and how they fit together in the bigger picture to create a website. So let's get started. So at the base level, before I start, I'm kind of not a big slides person. I made these slides so that after you guys can take them and kind of use them to have the diagrams after. But I am a big whiteboard person. That's why both of these are here. You'll notice in Coding Dojo we have tons of whiteboards. I love whiteboards. It's a great way to diagram and show people what you're actually talking about. So I'll be using the whiteboard a lot in conjunction with the slides. So we're going to start with the client-server model. The client-server model is something that the web is based off of, but it's not just the web. And the client-server model has two very key components that I'm sure all of you can guess. It's the client and the server. Now the key here is that the client is a service requester and the server is that service provider. But another key is that the client doesn't really care about how the server does its job. All that the client cares about is that it's going to get its service provided to it. And all that the server cares about is that the client is requesting some service and it has to provide that. The server doesn't care what the client does with that service after it is provided, and the client doesn't care about how the server creates that or packages that service and then provides it back. So this is the fundamental model. Can I get some kind of shout outs on where you may have seen this in the real world? Where, yeah?
Any iPhone or Android app.
OK, let's take it away from technology. Kind of putting technology aside, where have you seen this? Restaurants, perfect. ATM, great. Others? Banks. Restaurants are a really good one. Let's go with a very kind of well-known one, McDonald's. So this is an analogy that I like to use a lot with our students. And it's really helpful to understand how the client-server model works. And we'll be talking about this first. Then we'll jump into how that model is applicable to the web. But we'll start with this analogy. So with McDonald's, let's draw out our basic client-server model. We have a client, and we have a server. What's our client? Who's our client? Any customer. Anybody who wants a Big Mac, right? Any customer for McDonald's. What's the server? McDonald's, right? Easy enough. McDonald's, and our client is a customer. Now, say I'm the customer. When I go to McDonald's, who do I hit first? Who do I talk to first? When I walk through the doors, who do I go to first? Whoever's at the counter. Let's just say counter. We can say cashier here. That's the first line of defense. That's the first line of defense in McDonald's. They decide whether I'm a customer that they can serve or not. Right? The first thing they do is they look at me, they say, hey, is this someone who we can serve? Yes, it is. So let's see what they want. They take our order. So we, as the client, submit an order to the cashier. We don't care what's happening beyond the cashier. All we care about is that if I pay a couple of bucks, I'm going to get a Big Mac. Right? After the cashier, what happens? What happens in McDonald's? What does the cashier pass that order to? Who does that cashier pass that order to? Kitchen. Right? Perfect. The kitchen. There's someone in the kitchen making your Big Mac. But they can't magically just snap their fingers and have a Big Mac appear and hand it back to the cashier. What do they need to do to make that Big Mac? They need to cook it. But where do they get the supplies? There's some fridge. There's some fridge, there's some pantry, something that cook can go to, get the patty, get the bun, get the lettuce, get the tomatoes, bring it back, and actually grill, make the Big Mac, and then give it back to the cashier, who's then going to fulfill the order and give me back my food. Easy enough? All that happens here is that me as the customer, I want my Big Mac. I go to the cashier, I submit an order, and sometime later, I get the food back. Let's go back to our key point. Does the client care how it's made in the kitchen? Well, to some extent. The client just cares that he or she is getting back good food. But they don't have any insight into what's happening back here. And does the server care whether I'm going to take that Big Mac and give it to the homeless person outside, give it to my son, give it to my mom, my dad, whoever? No. The server just cares that, hey, we had an order submitted, and we're going to provide that food. So let's relate that to, this is kind of for if you take the slides back and you want the picture, you can get it. Let's take that to the web. Right? Let's erase all of these that we put on here. Let's fill in the components for the web. Now, for the web, what do you think our client is? How do we submit an order in the web? What medium do we use? A browser, exactly. We use a browser. We type in www.google.com, some magic happens, and we get the Google web page. Now, what we're doing, that magic, is that we are submitting an order, right? In the McDonald's example, we called it an order. What it's actually called is an HTTP request. We are requesting some data from the server. We are requesting the Google web page. Do we, as the client, does the browser care how the server is going to serve that up? What happens back here? No, we just care that we get www.google.com back, right? But what happens back here is important for us because this is a web architecture talk. So the first thing that happens in our McDonald's analogy was the cashier. There's a front line of defense. The first level is something called a web server. And this web server just decides, as in our McDonald's analogy, whether or not we can take in that request, whether or not we can accept that request, whether we are the correct server to serve that data that is being requested. And the web server says, OK, yes, we are. We are the right server that can serve that. And we are going to pass this request on to some logic unit. Our logic unit is kind of like the cook in the kitchen. It's the kitchen. It's whatever is putting together, taking the data, the raw data, packaging it together, giving it back so that it can be sent to the client. Right? That's the job of the logic unit. And we'll go into more specifics and place actual technologies here in a second. That logic unit, just as in our McDonald's analogy, needs some raw materials. And it gets those raw materials from the database. I'm going to draw this a little more kind of techy as a server rack. And that database, we request data from it, and that database serves that data back to the logic unit. We then send back an HTTP response. And the key here is that this HTTP response comes with, or is in the form of 3 languages: HTML, CSS, and JavaScript. And those 3 languages are the only 3 languages that can be interpreted by our browser. That's why the client doesn't care about what the server is doing back here. All the client cares about is that it's going to get HTML to define the elements on the page, CSS to define how those elements look, and JavaScript to define the behavior of those elements. These are the only languages that run on the client. Why? Because the browser has the ability to interpret those languages, and only those. Can you run Python here? Can you run Ruby here? No. You run HTML, CSS, and JavaScript. So wait, where do Python and Ruby come in? Where do we use those? That's on the back end. So let's get into some technologies now. Name some technologies for me that you have no idea what they do or how they fit into the bigger picture. Just anything you may have heard. There's tons of buzzwords out there. Name them.
Apache.
Apache. Apache is a web server. Goes right here. What's another one? Tomcat. Another web server. Another one. Ruby on Rails. Great. Ruby is a language. Rails is a framework for Ruby. They both fit into this logic unit. They're both used to put all of the pieces together and create that final product. Other technologies, I'm sure you've heard of tons. I've heard of Python. Django, great. Python is a language. Django, just like Rails, is a framework built in Python to help with this logic piece. Any others? Feel free to shout them out.
Spark.
Spark. I haven't heard of Spark, but I can look that up. And PHP, another language here. Others? Laravel, a framework for PHP. SQL, great. SQL is the language we'll use for a structured database. Others? Nodejs, great. Nodejs is a little tricky. Nodejs is, some people call it a library, some people call it a platform. What it is it's an implementation of JavaScript that can run on a computer. So traditionally, the browser has an engine that interprets JavaScript. Node.js is actually an interpreter that's been built on top of the V8 engine that's used in Chrome that allows you to run JavaScript on the back end. So some people use Node.js to create a server, but some people also use Node.js to write the JavaScript logic that goes in our logic piece here. Good one. Others? Jquery, great. Jquery is a JavaScript library that is often used on the front end to dictate the behavior of our elements. There's tons of these front-end frameworks. There's Angular. AngularJS, many of you may have heard of that. Some of you may have heard of Ember.js. That's another one that goes here. My point of doing this is that with any technology that you hear, any buzzword that you hear that deals with the web or is in the web model can be placed in this diagram. And by placing it in this diagram, you automatically know what it does. You don't need to know how to use it, but you know what it does, and you know what its purpose is. If there's a JavaScript framework here, its purpose is to dictate the behavior of the elements on the front end. If you have a piece that goes in your logic unit, its purpose is to package all of the final response and help send it to the client. Any other technologies that anyone's confused about? Where does it go? Swift is a different one. Swift is a language that's used in the iOS framework, so that gets into mobile. But mobile can fit into this model as well. Mobile can fit in because your app, your phone, is in and of itself a client that can request some data from the server. So you can have a little, sorry for those of you in the back if you can't see, let me draw that on top. You can have a little phone client here that makes requests and receives responses from the server as well. So it's another client. But you can see already how this client-server model is applicable to more than just the web. Any other technologies before we move on? Nginx, good question. Nginx is a web server. Any others? Cool. If you have technologies that you're confused about, this is meant to kind of demystify those technologies. So if you do, feel free to come up to me after. We can place them on this model, and we can demystify them. To kind of show our database some love over here, there's MySQL. There's PostgreSQL. There's MongoDB. There's tons of databases, SQLite, et cetera, et cetera. It just felt a little neglected over there. OK, so let's take this one step further. I'm going to redraw this a little smaller, and we're going to talk a little bit about scalability. Most people say, OK, well, Jay, that's great, but that seems pretty small. What if I have tons of people? How does that change? And the answer is, you have your basic client-server model. And the client makes requests to the server. And the server serves those responses. Now, if you want to scale, let's go back to McDonald's. How would you scale McDonald's? Say the line is out of the McDonald's store. How would you scale that up? You want to accept those customers, but now customers are going out because the wait is too long. How would you scale that up?
More counter people, more people in the kitchen.
More cashiers, more people in the kitchen. OK.
More supplies.
More supplies, more of everything, right? What else could you do?
Raise the price.
Raise the price, OK. More stores, exactly. More McDonald's, line them up next to each other. Have someone in the front saying, hey, you go to that first one. Hey, you go to that second one. Right? This is all doable in our client-server model. Right? We have our web server, we have our logic unit, and we have our database. Right? We can scale each of these components up. We can make them do more. We can make each of these components handle more traffic. Or we can scale out. We can have more actual replications of this. We can have a load balancer in front that balances all of the traffic. Now here's the question, though. If I were to ask you, or if someone were to ask me, hey, my website, everything's working, but when someone goes to my website, it takes 10 seconds to load. I'm losing people because of that. What would my first instinct be? What would my first instinct be? Would it be to increase the amount the web server can handle, the logic unit can handle, the database can handle? What would I do? What would my first step be? Would it be to first up the number of cashiers that I have? Call Comcast. No, the answer, yeah, you could take the orders first. You could throw out a million things. You could say, hey, and many people do this. You could say, hey, the logic unit here, going back to the technologies, is written in Ruby. Ruby's not fast. Why don't you rewrite it in C++? You can ask yourself all of those questions. You can go days saying, hey, let's rewrite this. Oh, MySQL is slow. Let's use a NoSQL database like MongoDB that's faster. You can do that all day. But the real question is, where's the bottleneck? Where are things slowing down? If your database is really slow, if this is taking like 0.001 seconds, this is taking 0.00001 seconds, and this is taking 9 point whatever seconds, does it help to make this logic unit faster? No. You haven't fixed your bottleneck. You have not fixed the fact that the database is being slow. So the point of this is you can scale up each of these components, but you need to first ask yourself, why are you scaling those up? Before making the decision to move from Ruby to C++, you need to ask yourself, what's actually slowing us down? Right? Any questions on this so far? Awesome. Cool. So this is the HTTP request response cycle, the client-server model for the web. We call that the HTTP request response cycle in diagram form for you guys to take back. And then here are some common questions that I typically get from people who are kind of just starting their coding journey. A couple of them, what is a framework? What's a library? So Rishi asked, OK, Ruby on Rails, or he said Ruby on Rails as a technology. Ruby is our language. Rails is our framework. Now, we already know that a framework, because I said it, is a set of tools built on top of Ruby. But what differentiates a framework from a library? Any ideas? What differentiates a framework from a library? A framework dictates some structure. A library is a set of tools. So great example is Jquery. Jquery is a library. It provides you with some functionality, but it doesn't dictate the structure of how you should structure those files, the code itself. Right? Rails is a framework for Ruby. It's called a framework because when you do Rails new and then the project name, it creates a bunch of folders and a bunch of files for you. So it defines that structure. This is a really good one. Why are there so many technologies? It's a really good question. And the answer to that is there are so many different use cases. There are so many different uses for all of these technologies. And many people go days saying, hey, one developer friend that I have said I should write all my whole product, my whole backend in Python. But another said that Python sucks, you should use Go. And that's something that happens every day. And the answer is, it's not necessarily that one language may be better for you than another, or better in all cases than the other language. It's that it depends on your use case. It depends on what you're trying to get out of it. It depends on what you're using the language for. Many people say you should use Python for data science. Why do they say that? Is it because Python is inherently good for data science? No, it's actually not. But the reason they say that is because Python has several libraries that help with data science built in Python. So not only do you have to look at the language itself, but you have to look at the tools that are built in that language that can help you achieve what you're trying to achieve. At the end of the day, many of these technologies achieve the same goals. And it's up to the developer preference. And at that level, someone may prefer using the mean stack, full JavaScript from front to back, to using Ruby on Rails. and that's a developer preference. But the short answer to this is there are many different use cases, and you have to evaluate how are you going to use that technology. And more importantly, if it's a language that you're choosing between, how are you going to leverage the tools available in those languages to achieve what you're going to achieve? And yeah, that was how do I choose a technology to use? You really have to ask yourself, OK, what am I trying to do? And what libraries are there in all of these languages that I can leverage to achieve that? More importantly, what do my developers know? And what do my developers know well? What can they code in well? Right. Cool. Any questions, guys?
So can people speak different languages talk to one another?
Yeah, so it's a good question. All of these languages are, at the end of the day, the language itself, they all have the same basic building blocks. They all have a way to loop through, loop multiple times. They all have a way to have a conditional flow. They all have a way to store information. Right? All of those fundamental building blocks of coding are the same. But what's really important is the libraries in those technologies. So a developer who codes in Go can definitely talk to a developer that codes in Ruby, and they can talk about logic. Can they necessarily talk about their actual syntax? No. But a pro tip is a good developer can learn any technology. A good developer can switch between languages very easily because they've kind of pulled the logic off of that.
So can the output from a program written in one language be used as an input in a program written in a different language?
That's a good question. So there's these things called, nobody asked about APIs. Man, I was hoping someone would ask about APIs in that shout out of technology. So an API is an application programming interface. So if you want to have one application written in Go talk to an application written in Ruby, you need to have some interface between those two, some way that they can pass data between each other. There's API endpoints where you'll have, and those can work in a client-server model as well, right? You can have one Ruby application request something from a Go application, and there can be an endpoint for the Ruby application to request, and that Go application can give something back. This request and response can be in the form of HTTP, TCP, anything. It doesn't even have to be a protocol like that. Yeah.
So both has to have the API structure?
Yeah, so one has to know, if we go back to the client-server model, one has to know what it's requesting, and the other has to know how it responds to that request. So this is basically an API. The server has specific endpoints that it can serve responses for, and the client knows what endpoints to request and what it's expecting back from those. Yeah.
Where is that the XML or JSON thing
Yes.
fits in?
Good question. So this is our HTTP request response cycle. We have HTML, CSS, and JavaScript on the browser here. Now we send an HTTP request, and we get back an HTTP response. Now the HTTP response is in the form of HTML, CSS, and JavaScript. JSON and XML, JSON, I'll talk about JSON first. They both achieve the same result. JSON is a way of modeling data. JSON stands for JavaScript Object Notation. So it's how you write objects in JavaScript. And in JavaScript, an object can have nested objects as well. Now we're getting into code, but basically, at the base level, JSON can represent any data in the world, which is why it's used as kind of a form of writing data, organizing data, to pass data back and forth. So you can, many times for APIs, you are requesting JSON data, and you're getting that JSON data back. Ajax, Oftentimes, many people in that kind of shout-out session where you shout out technologies, many people say Ajax. What is Ajax? Ajax is a way of making these requests and receiving those responses. And the X here stands for XML. And basically, it's asynchronous JavaScript and XML. And what you're doing is you're making a request without actually physically going there. It would be as if, in the McDonald's analogy, I went on DoorDash and had them go get the McDonald's for me. And I just told them what exactly I wanted. And basically, the XML here now, in most cases, has been replaced with JSON. They're both ways of representing that data. Any other questions?
So are all these languages written in English, or are there other types of languages like in Russian or Chinese that accomplish the same thing? Like if Python was written in Chinese, would it not be called Python anymore? Does that make sense?
That's a good question, Paul.
Thanks, Jay.
It's these languages, you write them in English. Yeah.
Are there computer languages that are not in English?
I bet there are. I mean, there are computer languages that are written in like underscores and spaces and periods. They don't have any letters. So I'm sure someone's made a computer language with Chinese characters or something.
Doing everything in French. They even have their own word for computer.
Oh, wow. Yeah. I didn't know the answer to that, Paul. Yeah. Other questions?
Describe the place of CMS. Where is the CMS?
Yes. So CMS, Content Management System, is like WordPress, Drupal. They're basically kind of kind of created or packaged implementations of these servers here. It's actually of the logic unit here. For example, WordPress is technically actually a framework built on top of PHP. And it allows you to create those websites more easily and handle that content. Parse? Yeah, it would be. That's more data related. Yeah, so it handles more of this side. Yeah. Other questions?
So what's the key difference in JSON and XML?
Yeah, it's just JSON and XML. It's just the way that the data is represented. They both achieve the same result. It's just how you physically write it out. They both achieve the same result of modeling the data and packaging it so that you can send it back and forth.
So JSON has more preference than XML, is that?
Lately, I mean, most APIs that people use now use JSON. Yeah. Other questions? IDLs? IDL. I'm not sure what an IDL is. I haven't worked with IDLs before. Yeah. I have one more slide here to get you guys kicked off. Most of the time in the past when we've done this talk, it's been designed for people who are really trying to kick off a self-study in web development. And we have this where to start. What I would suggest to all entrepreneurs, if you're saying, or if you're asking yourself, where I have this product idea, I want to build it, but I don't know how to go about that. I'm not technical. I can either learn these skills or I can get a technical co-founder or hire someone, etc. The place to start is just wireframe your idea. Wireframe your idea first. Jot down some notes about what data you're going to have to hold on to, what data you're going to have to store. And that does two things. That first tells you about this piece. It clues you into your needs on this piece, the HTML, CSS, and JavaScript. And it also clues you in on, to your needs on the database level. And then after you wireframe, you should always build out kind of a clickable prototype. And there are many tools that can be used nowadays to build out those clickable prototypes. But build out the clickable prototype, build it in HTML, CSS, and JavaScript, and then you can kind of add in the backend framework. And you can learn these as you go through. And selecting the backend framework is often the hardest, but my advice is talk to someone, see what they recommend, and then just jump in. If you talk to 10 people, they'll give you 10 different answers. And not any of them is necessarily the right one. They all may be the right one. That's the point. Other questions?
We hear about this REST code.
Yes, yeah. So REST and RESTful architecture basically defines some principles to use when creating kind of your full stack, your backend, in the full stack specifically. But more importantly, where you'll hear it the most is when you hear RESTful API. And that basically says it defines the series of endpoints for your API, a typical series of endpoints for a particular resource, a resource being people, users, posts, whatever a resource may be, like anything that you would store in your database. And a RESTful API is one that conforms to the typical way of presenting those resources. So like one, presenting a particular user, presenting all the users, adding a particular user, updating a particular user, deleting a particular user. All of those actions, a RESTful API conforms to kind of a set of principles on those. And the reason it's important is if you were to tell someone, hey, I have a RESTful API that you can plug into to get blah, blah, blah data, then they automatically know what to request, what endpoints to request. Those endpoints being URLs. Yeah.
So why someone wants to go for RESTful than the regular API? What's the key difference?
Basically, if I'm using, like say I'm using the Yelp API, the Yelp API is RESTful, then I know how to use it automatically. I know what endpoints are there, what I can request, how I can request it. It's very easy to use that API. Versus if something's not RESTful, then you have to learn how that API, what endpoints that API has, and what those endpoints do.
Don't they provide any documents? Like
they can provide documentation, but this just makes it one step easier, right? And it also enforces some structure. When I'm requesting something from an API, if I know it's RESTful, it takes me 5 seconds to start using that API. Versus if it's not RESTful, I have to go in, really read through the documentation, figure out how I'm going to request what I want, and pull it back.
Okay, yeah, got it.
Other questions? SOAP. SOAP is kind of another form of this. Yeah. There's REST and there's SOAP. Other questions?
Are there some good references on this that you would recommend? Basically a progression of references?
Well, Paul will tell you more about coding data. No, I'm joking. So really for wireframing, the tool that I would suggest there is Balsamiq or Mockups. That's an actual tool to create your wireframes. Once you get started with that, HTML, CSS, and JavaScript, they're pretty, HTML and CSS are relatively easy to learn on your own. Any free resource like Code Academy would be great for that, for HTML and CSS. JavaScript is a little trickier because most of the time you won't be writing vanilla JavaScript. You're not going to be writing straight in JavaScript. You're going to be using some front-end JavaScript library. So if you want to get your feet wet, start with jQuery. It's pretty easy to pick up if you've gone through a JavaScript Code Academy course. And you can use any number of resources for that. There's a bunch of free ones. I don't have any that come to mind for jQuery specifically. And then for the backend framework, once you decide on one, I would decide on something that is a good medium of robust, a good kind of in-between point between very robust, doing a lot for you, and kind of like a micro framework. You don't. The two sides of the spectrum are, one does so much for you that you don't necessarily know exactly what it's doing, and if you wanted to have a little more control, a little more customization, then it would be very tough to get that with a very robust kind of structured framework. And then the micro framework doesn't provide as much at all for you, but it provides you the base tool so that you can build upon that, sort of kind of get yourself to the robust level, but in a more specialized way. So I would choose a good in-between, probably more on the robust side if you're just starting out and you're an entrepreneur who wants to get their product up quickly.
Just one thought. Just one thought. If you're going to like pick up a book to learn something like HTML, it might be best going to the bookstore and getting the latest and greatest book on the subject. For example, you want to start learning HTML5. There's no point in learning older technology that's already going obsolete. So.
Yeah. Great point. HTML5, CSS3, if you're learning those.
What's the tool available for monitoring this performance stuff you said?
Yeah, so for monitoring performance, there's various tools available. And really, when you get to that level, you want to have a good medium between already built tools and, more importantly, things that you build yourself to monitor specific things that you want to keep track of. And it really depends on how a database is a critical piece in that sense, because it really depends on how your database is working. Not all the time, but most of the time, many bottlenecks are at this database level because you're making all of these apps are data-driven apps. You're making a lot of queries to them, and those queries may be either slow or you're querying a lot of data and the database is taking some time. So if you're using something like Firebase or an easier database to use like that, that's a service, then they'll have monitoring built in. Otherwise, there's various, I can get a lot more technical, but I'll talk to you about that after.
I have 2 questions. So where does C++, Java fit into this picture? And then also, like, when will you choose MongoDB over SQL?
Great question. I like that second one a lot. The first one was, where do C++ and Java fit into this picture? So C++ and Java, both languages, C as well, they fit into this logic component. Some of these web servers are built in C. And so they can technically fit in all of these components, but most of the time you would see Java or C++ in this logic component here. For MongoDB versus MySQL, it's really that's a great use case question. That's the difference between SQL. I'm going to erase this a little bit. That's the difference between a SQL and a NoSQL database. And what that means is, really at the fundamental level, NoSQL. Really at the fundamental level, you're talking about structured versus not structured. You're talking about also tabular versus not tabular. And you really have to ask yourself, a lot of people say, okay, hey, MongoDB is blazing fast. But that doesn't necessarily mean that it's the right thing to use if you have very tabular data. Also, a big thing here is each, you call them documents, each document here in NoSQL is self-containing. So you could have associations between data, but if you're going to have a lot of associations, you want a more tabular database than a NoSQL database. So you really have to ask yourself those questions and then arrive at the answer of why you would use MongoDB versus MySQL. That's not too often we see people saying, hey, MongoDB is better than MySQL. And that is the wrong thing to say, because they have 2 very different use cases. Any other questions?
Could you give an example of some type of data which NoSQL is more suited for?
Let's see. So, okay, let's say Amazon's products. Each product is a little bit unstructured. There's several products, but each product would be one, self-containing, but two, generally unstructured or different structure between product to product. One product may be a book that has an author field that it needs to keep track of, while another may be a DVD that has a director field. So for that, I would use a NoSQL database. Versus if I was building Facebook that had users that have friends and each user has a wall post and those wall posts have comments, then that's more kind of associated data across several tables. But also each of those things that I mentioned generally has same kind of fields, structured data, could be very tabular. You would use SQL for that. Generally, if you can model something easily, if you can imagine it in your head in Excel, use something like this. If it's like Amazon's products is a great example. That's something where each product, you have a series of products, but each product could be vastly different in what they need to keep track of. Yeah. Other questions?
How do you choose API endpoints?
Yeah, great question. So, if from the someone who's building an API, yeah. So, if I were building an API, and let's say that the API was providing, let's say, traffic data, right? The point of the API is to provide that data in a nice, digestible manner, right? So I would have to think, okay, my users, the people who are going to request that data from me, they need to have certain sets of data. So I should think, okay, what type of data could they request? A word of caution, you can get into a rabbit hole doing that. So you generally want to stay more general and say, okay, I'm going to provide these sets of data and let that client do more of the processing on their end. But you have to kind of try to foresee what data are they going to actually want. Any other questions? Yeah?
So what would be the benefit of an on-site coding class versus, self-learning?
Yeah, so obviously I'm an instructor here at Coding Dojo. I would always suggest on-site. We offer an online course at Coding Dojo. I would suggest on-site because, it honestly depends on the on-site atmosphere, but at least here in Coding Dojo, you're with a lot of other people who are also learning. Also, for me, I have a tough time learning online. You just really have to set a schedule for yourself. You really have to stay on that schedule. You can't get knocked off, and you need some direction. With coding especially, there are so many resources online. And it's a great thing. It's a great thing that there are so many resources online, but it's also a crutch at many times because some of those resources are more tutorial-based, where you go through the motions, but you don't really learn anything. Others have a lot of roadblocks in them that you just can't pass, and then you learn a little bit but shoot to another one. And more often than not, all of those different resources teach different ways of doing things. So you can get a lot of conflicting information as well.
Just one other thought. I'm mostly self-taught. I spent a lot more time going down that path than if I had taken some courses. And I also picked up a lot of bad habits along the way, which I had to unlearn. So,
yeah. We get a lot of self-taught developers that come here and want to kind of have a more structured way of learning. Yeah. Other questions?
We talk about project-based learning.
Project-based learning. I love project-based learning. Project-based learning is literally exactly this. You know what you need to build. So you have a lighthouse, right? You need to get there. and you just do that over and over and over again. You know, what we do here at Coding Dojo is we have like over 200 assignments that students go through. And it's really, one of the things that we always say in our curriculum is you do not want to build, for us internally, we do not want to build tutorials. Why don't we want to build tutorials? Because we want students to struggle. That sounds a little mean, but we want students to struggle because when you are figuring out how to build something, when you are given a wireframe to build, and you are trying to figure out how to build that, you are learning things on your own and you're training yourself to be a problem solver, which is really at the fundamental level what a developer is. I mean, whenever I start a cohort or I'm talking to an open house or something like that, it's always, we don't teach people how to code, we teach people how to be developers. Teaching people how to code is a very small subset of that. We don't just teach people how to code, sorry. Teaching people how to code is a very small subset of that. Being a developer is all about problem solving. Any developer you talk to will tell you that. Yeah, so it's great to have kind of a lighthouse and just get there, see the next lighthouse, get there, so and just keep iterating on that. Yeah. Other questions? Other questions? I could talk all day. Awesome. Thanks, guys. I'm here for, I think, another hour or so. So please come up to me and ask me questions. I love learning about what people are working on. If you have a product that you're trying to build and you want some advice on what technologies to go with for that specific product, let me know. I would love to help you and offer any advice I can. Cool. Thank you.
We'd like to thank our speakers at IPO events. I used to give them these IPO jackets, but they would never wear them. So now we're giving them coffee mugs.
Thank you.
So let's hear it for Jim. Paul's got something to say.
Yeah, so Paul will tell you a little bit about Coding Dojo. I don't want to kind of go straight into the plug, so he'll do it for me.
So I'll just make this quick. I got a few questions beforehand about the program that we have here. So real quick, my name is Paul Schindler. I work for Coding Dojo as the Community Outreach and Business Development Director here. And one of the biggest things that we offer, I think that's different, that you're going to see at other boot camps, is that we teach 3 full stacks in 3 months. And that might sound a lot, but really once you get started into it, we think we have a good product. Basically, if you're looking at a full stack, kind of like what Jay was talking about, you have things that incorporate multiple technologies into one platform. So you can build a full web application, website, product, whatever you want, using that stack. So for example, we teach LAMP, which is a combination of Linux, Apache, MySQL, and PHP. We teach the mean stack, which is MongoDB, Express.js, AngularJS, and Node.js. Along with Python, Ruby on Rails, iOS, Swift, and I'm missing one more. Am I missing one more?
No, I think you got
Python.
it. Python. You said Python.
I said Python.
You're good.
Okay. And so that's kind of the program in a nutshell. You know, if it's something that you're interested in, talk to me afterwards. I have my business card. We give tours here all the time. You know, we have a pretty diverse group of students. It's really good. I could say that the common factor that most people do bring when they come here is motivation and desire to learn. A lot of people have a background in programming when they come, but a lot of people don't. I'd say probably over 50% don't have a background in programming, but they do come hungry to learn programming. So make no mistake about it, it is a difficult program. Coding and programming is. If it was easy, everybody would be doing it. But if you do have the dedication and desire to learn how to program, we'll meet you there and we'll help you through that. So that's all I have to say.
What's your placement rate for graduates?
Yeah, so that's a good question. Alyssa would be a better person to answer about this because she's the community services manager. But well, I guess she comes up here now. Okay.
Okay, so my colleagues and I are always. This was your question? Okay, my colleagues and I are always recalculating the statistic. Right now we're at 91% of graduates graduating within, getting a job within the technology field within 3 months of graduating. So. The average starting salary company-wide, and that's taking into account our campus in Burbank and Seattle, is $77K. Within the Silicon Valley, especially given the marketplace that we're in, it's at 91,000. Yeah. 91 seems to be the magic number right now, so.
Sounds good. Great. Oh, and in case you guys are bedazzled by that 91,000 number, it is hard work. Again, I just want to ingrain that. It's not something as simple as reading a book. I know you mentioned picking a book up in the library. I mean, good luck. That's probably the hardest way to learn how to program is reading a book. You got to struggle through it. And we're open 24/7 here. We don't close. And our students are here, I would say maybe on average 70, 80 hours a week kind of thing. It really is kind of committing yourself to something that people spend 4 or 5, even more years learning. We'll knock it out as fast as we can, but you do contribute a lot.
What if you're a non-technical person and a dummy? Can you turn people down?
So we have a kind of a breakdown in how to program, right? How to learn how to program. We begin you off with algorithms, basic algorithms that are fundamental for any kind of programming you're going to do in the future. Then we start you off in HTML and CSS, sort of well, it's erased now, but the front-end languages that are a little bit easier to pick up. And then from there, we're going to start you with the fundamental stack. So either Python, which you guys probably heard is one of the easier stacks to learn, one of the easier programming languages to learn. So we start you off with Python or PHP. And then from there, we ramp it up to Mean, iOS, Ruby, depending on the technology that you want to get into. So, I mean, you can talk to the students here. They'll tell you over half of them don't have any programming background. Most of them are marketing or HR.
I'm actually a current student right now. I've only been here for about 2 weeks or so, and I didn't write 1 line of code before I got here. The only advice I can give is to put time into it because it's not going to happen any other way. I get here around 7 every single morning, and I don't really leave until 8, 9 o'clock at night. Obviously, you take breaks throughout the day, but you have to be devoted to it. So for me, I tried learning online, but there's so many distractions with just doing literally anything when you're at home. But when you're here, you come here in the morning, you know all you're doing is coding until you're leaving. So it's kind of what you make of it. You get out of it when you can do it.
Well said.
We should take Ben to all of our events.
What are you doing for the next 2 weeks, Ben? No,
You're hired. That connection, do you have any part-time programs, or does that not even work?
That's a good question. It's a complicated answer. Right now, we don't have a part-time program. I think part of that is limited to space, and part of this limited by practicality. It is going to be hard to teach you full stacks in an evening type of cohort. We do have a front-end web fundamentals part-time program that we're running in Seattle. We're going to be implementing it here in San Jose in the next maybe two months, maybe? Hopefully.
Yeah, couple
I'm trying
months.
to convince Jay to do it. But so yeah, we have that, which will teach you CSS, HTML, and some JavaScript through Jquery. But again, that's going to be an evening course. We don't actually have a full part-time program. The closest thing we have is an online program, which the lectures are recorded, you have a mentor, and you can work at your own pace after work. And so I think a lot of people that are working currently are going to be doing that program. And then they have access here if you're local as well. So, okay. Any other questions? Sounds good. Thank you.